In this video, we'll be talking about how to name ionic and covalent compounds that are not acids. We'll cover acids in another video. And to start this video, we're first going to focus on how to name or how to identify the bond type of different compounds or the different type of compounds that we have. So first, we have a metal bonded to another metal. Typically, it's not just going to be one metal and another metal. It's a large group of metal atoms all bonded to one another. And the name for this, as a hint, we're going to use what we have, metal and a metal. Well, the most obvious name would probably be a metallic bond. So it's not a trick question. If you have a metal bonded to a metal, and you have a multiple choice question, and one of the choices is a metallic bond. And a metal, keep in mind, metals are on the left side of the periodic table. They would rather lose electrons than gain them to get to 8 valence electrons. And so they form positive charges. Metals always form positive charges. I can't think of any exceptions to that rule. Metals form positive charges. So two metals bonded to each other, metallic bond. Next, we have a metal bonded to a nonmetal. These are where we have a transfer of electrons. And what happens is one atom, the metal, is really interested in giving away electrons. And then the other atom in the compound is really interested in taking electrons. So the atom that's giving away electrons, we just said that metals like to do that. So that's why they form a positive charge. And the one that's taking electrons, that's gaining negative charges, is the nonmetal. So let's look at an example real quick. So the most common example that you're probably going to be familiar with is sodium chloride. So we have sodium here, and sodium has 1 valence electron because it's located in the first column on the periodic table. And then we have chlorine here, and chlorine has 7 valence electrons. All right, and chlorine really wants to get to 8 valence electrons. So does sodium. So chlorine, it's easiest for it to gain 1 electron, and it's easiest for sodium to lose 1 electron to get to 8 valence electrons. So chlorine is going to take that electron from sodium, and sodium will gladly get rid of it because through giving away this electron, sodium will get to 8 valence electrons, and through accepting that electron, chlorine will get to 8 valence electrons. So this is what an ionic bond is. So an ionic bond, we've kind of had these simple definitions of it's a metal bonded to a nonmetal, or a difference in electronegativity of greater than 1.8 or 2 or whatever value your teacher gives you. But really, when it comes down to what it actually is, it's a bond where there is a complete transfer of electrons. So sodium and chlorine is a really good example of that. And let me draw the rest of this so that we can really understand what it's representing. So we have sodium here, and sodium now has a positive charge. And then we have chlorine here with all 8 electrons around it. And it has that 1 from sodium. And it has a negative 1 charge. All right, so chlorine took that electron, sodium gave it away, and we have something with a positive charge bonded to something with a negative charge. Specifically, a metal with a positive charge bonded to a nonmetal with a negative charge. All right, now let's look at. We said that pretty much anytime we have a positive charge bonded to something that forms a negative charge, that's going to be an ionic bond. The exception is going to be acids, which will be covered in a different video. But a metal bonded to something with a negative charge, well, in this case, sometimes we have polyatomic ions that have negative charges. Many of our polyatomic ions are negatively charged. So same thing, this polyatomic ion is interested in taking an electron, and this metal is interested in giving one away. So same thing, it's going to form an ionic bond. All right, well, what if we have a polyatomic ion and another polyatomic ion? Well, that's tricky because polyatomic ions, sometimes they form positive charges, sometimes they form negative charges. But I'm going to give us a hint and say that every time, except for covalent bonds that are not acids, any element that is on at the start of the chemical compound formula, is always going to be positively charged. All right, nonmetals, except for hydrogen, always form negative charges. So we're just kind of filling in some of these extra ones. And then if we notice, we probably notice a trend that the second element in a bond is always a negative charge. So that might have been a little bit confusing, but we'll just leave it in simple terms for us. A polyatomic ion bonded to another polyatomic ion is always going to form an ionic bond. So if you just want to memorize that, you should be fine. Next, a polyatomic ion bonded to a nonmetal is also forming an ionic bond. The exception would be if the nonmetal is hydrogen. Then that would be an acid, but more on that later. And if the nonmetal was a hydrogen, the hydrogen would be written before the polyatomic ion. So it's another thing to look out for. Next, we have a nonmetal bonded to a nonmetal. So typically this is going to be something with a negative charge and a negative charge. The exception is hydrogen is really the only nonmetal that's going to form a positive charge. And but typically a negative charge bonded to a negative charge. And in this case, we can't just have a transfer of electrons like this, because a negative charge and a negative charge, well, both of those atoms are interested in gaining electrons. Neither one is interested in giving electrons away. So we'll continue on with an example using, actually we'll use a different element than chlorine. Let's use fluorine, F. So if I have fluorine here, I have 1, 2, 3, 4, 5, 6, 7 valence electrons. And I'll have another fluorine with 1, 2, 3, 4, 5, 6, 7 valence electrons. Neither one of these fluorines wants to give away an electron. Not that one. Not that one. That's not going to happen either. So what needs to happen is they need to share a bond. And anytime there's a sharing of electrons, that is what we call a covalent bond. So fluorine is going to share these two electrons and form a bond right here. And so this will be a covalent bond. All right, now that we've got that down, we're ready to move on to the naming rules, because the first thing that we need to identify is the type of bond that we have. Once we know the type of bond that we have, we can look up the rules for naming compounds involving that type of bond. So I'm going to cut this off as part 1, and then part 2 is going to be the naming rules utilizing what we just learned in this part 1.